chapter 5 is solving systems of equations. A system of equations is more than one equation, and the solution is where the equations cross or where they have a common solution. We're going to do 5.1, which is the linear systems, where they're all straight linear equations. And then in 5.5, the nonlinear systems, which is over that stuff you've been doing like in your quiz today over conic sections. You may have a parabola with a line going through it. You know, if you have a parabola curve and then a line going through it, you could have two solutions, right? Or you may have a circle with a hyperbola, pretty cool, like a basketball, and then you would have four solutions. Remember, the solution graphically is where the two equations cross one another. So the solution is these crossing, coinciding points of the two graphs. Another example, maybe you'll have an ellipse with a line through it, so two spots. But now listen, guys, it may be that you have your ellipse and the line misses it. Sometimes that happens. So there will be no solution if the two equations do not cross one another. So that can happen, and we'll talk about how that looks algebraically. But in today's lesson, we're only focusing on 5.1, which are the linear systems. If you have a line and another line, the most that two lines can cross one another, because they're just straight, right? It can't curve back around and hit it. So the most that two lines can cross is just in one spot, if they cross at all. So one solution means that you have a consistent system. So most of your homework will be like that. You will be asked to solve the system. You will find that one point where the two equations cross. That will be your solution, and it will be a consistent system. Now, can you think of a situation that would where you would see the two lines not crossing? What would that look like on a graph? Parallel lines. Right. If you would have two lines with the exact same slope, but they're two different lines, unique y-intercepts, so two lines running parallel, you would have no solution. Okay, so parallel lines miss one another, right? No solution. Circle with a little line through it. And we call that an inconsistent system. When the two lines do not cross. Now there is a third possibility. And sometimes you can't tell it just looking at the equation from the beginning, but when you get the equation graphed, it winds up just being a line, and then the other line lies right on top of it. It's an equivalent line, a line on top of the line, and we call that a dependent system. And that's a line on top of a line, or just they're the same line. Algebraically, when you clean the equations up and put them in standard form or whatever form that you arrange them in, you see that they're equivalent. They have the same slope and the same y-intercept, the exact same lines. All right, so those are our three possibilities. And in this situation, you know, there's no solution, no crossing point. In our normal, what we'll call normal consistent solution is one crossing point. That's what happens most of the time. And then dependent, a line on top of a line, we say there are infinite solutions. You know, the solution is where the two lines would cross, where they're crossing all over the place, right? It's everything is on top of the other one, so they're crossing each other in an infinite amount of spots. So infinite solutions for a dependent system. So now let's talk about the methods for finding the solution. Okay, we have three methods for solving a system. Graphing. You can graph the two lines, look at your coordinate grid and see where they cross that way. Substitute. The other two ways are algebraic ways though. Substitution and then elimination or addition method. So let's start with graphing. So we've got two equations. I'll call this equation 1 and equation 2. So So if I go through the graphing method, just to remind you how we graph a line, there's a couple of ways to graph a line. I like to solve it for y and do the slope-intercept method. So I would say y equals negative x plus 5. So that's the mx plus b method, where the slope is negative 1, understood to be over positive 1. So slope and y-intercept of 5. So 1, 2, 3, 4, 5 y-intercept. Then rise negative 1, run positive 1. The rise over run. So down 1, right 1. Connect your dots, that's your line. Other ways of graphing that line would be just doing a t-table. If I plug in 2 for x, 2 plus y has to be 3 to get 5. I could plug in 0 for x, 0 plus 5 equals 5. And I could find combos that solve that as well. And then graph my line for my combos. All right, so once you graph your first line, then we move on. Graph number 2, x minus y equals 1. I'm going to graph it on the same grid. Throw the x across the line. You need to divide out the negative 1, right, because it needs to be positive y equals negative divided by negative makes that positive 1x. 1 over negative 1 is negative 1. So get it in y equals mx plus b form. The y-intercept is negative 1. With a 1 over 1, it's understood to be over 1 again. So that's up 1, right 1. Connect your dots. So this is a consistent system where the two equations will cross and give you one solution. The crossing point, the solution to the system, should be 3, 2. I don't know that I hit it perfectly on my graph where I wasn't on perfectly gridded paper, but it should be over 3 and up 2 to find that exact intersecting point. And you can also check it. It is true. 3 plus 2 is 5, and 3 minus 2 is 1. It's the one solution that solves both equations. All right, any questions on that? This isn't always a reasonable way to solve your equations, though, because sometimes you cross at a fractional amount and you can't pick it up with just your eyeballs. Maybe it crosses at 3 1/3 and 2 2/7. You know, you'll never be able to detect that with just your eyes. On a graphing calculator, it will pinpoint that number, and we can do it that way as well. But just doing it regular graphing on your own paper pencil method, that's not always the best way to go. So we have other methods. The second method, the substitution method, you take one of your 4 variables. You should have at least 4 variables. If it's just a 2-system equation, 2 equations, you should have 4 variables to choose from. You pick whichever variable looks easiest for you to solve for. You know, on this one, they're all pretty easy. You know, they only have coefficients of 1s in front of them, so they're not hard to solve for. But anyway, if you would have harder equations, you pick the equation that looks easiest to solve for. It's up to you. You pick one of the variables. I'm going to pick this x and throw the y across the line. So I solve for one of the 4 variables, then I sub that value into the x in the previous equation. So it says x is y plus 1, so I'm substituting that x as a y plus 1. So that's the substitution method. So y plus 1 plus y equals 5. The substitution method lets us solve a linear equation in only one variable because we sub it out with the same variable. We're able then to do our algebra to it. So minus 1, 2y is 4, divide by 2, y is 2. So we're able to solve and find the y solution. But remember, the solution is an x and a y. It's a coordinate. So you need the point. So y equals 2 is only half of the answer. We knew that from our other method, by the way. But now we need to pick up its x value, which you can do in one of your former equations. You can do it right here. X will be the y value plus 1. Now that we know y is 2, x is 2 plus 1, or x is 3. So the coordinate is 2, 3. Know that we could have got that same answer.
It's actually 3, 2.
What I do?
3, 2.
Oh, yeah. on your Math Excel work, so make sure you put these in the right order. X is 3, Y is 2. Must be in the right order. It is a ordered pair, so it must be in the right order. You could have got that X equals 3 from one of these equations as well, so it should give you the same solution whether you use any form of your former equations. Okay, so questions on that? So sometimes that's the best way to solve an equation. For example, if I had 3x plus 2y equals 20, 5x plus y equals 7, I could use substitution and I would pick this one y as the variable to work around. And pick the variable that looks easiest to solve around. So, you know, with one of these with coefficients, I would pick this y and say y equals, throw the 5x across, and then sub that in for the y above it. So that's the essence of the substitution method.